So now let's go into some more practical features of code. Like all these previous examples of like the color sensor and these math blocks, they're all useful, but you wouldn't use them by themselves. They're like components, they're small pieces of a bigger puzzle. And we want to put that puzzle together. So now let's talk about proportional line following. So what is proportional line following? You may be wondering, what the heck is this thing? What are these huge, big, fancy words? Well, you probably know the word line, and you probably know following, but what is proportional and all that stuff? Well, if you remember from our previous video, the proportional line following, or the proportion, is a value based off of scaling. And scaling is the multiplying of a number to increase or decrease the value by a certain proportion. So that's where we get the name proportional line following. But what is proportional line following doing? Well, proportional line following is what it says. It's following a line. And we can use all these previous components to create a line following code. And proportional line following requires reflected light intensity, and it follows the black and white lines on the FLL mat. And the basic concept of proportional line following is the farther away it is from the line, the more correction it has to get back on course. So let's just say that you're in the middle of the road and you're drifting off to the side. Well, the more you drift, the more correction you have, and the bigger the correction you have. And that's basically the idea of proportional line following. But to code this feature, and for a little more information and comprehension, let's watch this video. All the components that we've learned in the last few videos. We've learned about variables, we've learned about math blocks, we've learned about loop blocks and all their various different forms. We've learned about the color sensor and how we can get values. And of course, if you want to make your robot move, we learned about steering using the move steering block. So how about we all put this together? But how are we supposed to put everything we learned together into one code? Well, there's one exceptionally interesting code called a proportional line follow. Let me explain what proportional line following means. So, suppose you're biking on a road. There's no cars on the road, it's just you. You want to bike in the middle of the road because you don't want to go too far off to the side of the road and then crash your bike into the curb. But you don't want to be too close to the other side because then that'll happen to you on the other side. So you want to stay directly on the middle, directly on the dotted lines. However, what you do, you see two bumps up ahead. See a small bump and a big bump farther along. You see the small bump, and let's just suppose that the small bump is extremely smaller than the big bump. The bump is minute. So the big bump is huge. It's going to cause a lot of problems and you need to adjust your course. And that's basically the idea of proportional line following. The smaller the bump, the less correction it needs. But the bigger the bump, the more correction it needs. So our robot will be following these black and white lines in the FLL mat to align our robot parallel to these lines while constantly following it. So the light sensor is a very useful block, and we'll be using reflected light intensity. Next, we'll be dragging in our move steering block. Move steering is a very useful block in the way that if you have any kind of sensor corrections, I would always recommend using move steering because the way it performs is different than any other block. So now we have that part, and we'll need two math blocks for this. So let's just drag all of our math blocks in here. So let's remember from our math block video. what we have here is we have a few operations. So let's also remember back to the color sensor video. In the color sensor video, it said that reflected light intensity has a value all the way from 0 to 100 as a percentage, okay? So in that percentage, it can be like 45, 30, any number. And what proportional line following does is it follows the edge between two lines, a black and a white line. So basically, it's following the junction of two lines, the intersection of two lines, black and white lines, that edge between them. What it does is black does not reflect a lot of light. Black absorbs light, and white reflects a lot of light. And what we can do is we can say black is equal to 0, and white is equal to 100%, according to the color sensor. So what we can do is we can follow the middle of the line. We can follow different parts of the line. We can follow more black, like a number that's less than 50, or we can follow more white, a number that's greater than 50. The numbers cannot be 0 or 100 themselves, because then you don't know which is where. But, well, that's more of an advanced concept of figuring out that kind of stuff. And we can talk about that later in our next gyro video, later in this session. So here we have our measure reflected light intensity, and we're going to drag that into here. So remember what we had over here. This is our threshold value. And the threshold value is basically the target value. Because remember, if the gyro value was equal to 50, then 50 minus 50 equals 0. And that multiplied by -1 is going to be equal to the steering. And if it's 0, then the steering will not change. However, if it's like 3 minus 50, we get -47 multiplied by -1, we get 47 as a positive number. And then that'll adjust the steering. And then this is basically the idea, but using the color sensor. So what we can do is, let's say we want to follow 50% white and 50% black. The exact middle of black and white, black being 0, white being 100, is 50. So we can set our target value to 50, meaning that it'll follow 50% white and 50% black. So then this is the part where we start doing our operation factor, or scaling. Remember our scaling from the math block video? This is our scale. What we can do is we can make this multiplied by a factor of 0.7, meaning it's only 70% of its original value, and this is 50% of its original value. But now let's incorporate that concept into the proportional line follow. So we have our value, our difference from our threshold value, and what we want to do now is we want to do some scaling. Now what do I mean by scaling? So let's suppose our value in here is 100, meaning it's on white. 100 minus 50 is equal to 50. And if we were to directly put that into the steering, that is such a sharp turn that our robot might overturn and might go off course of the line. So instead, what we have to do is we have to scale it. You have to scale the factor down by a certain proportion, so that way the turns are less steep. Every different line on the table has its own proportion, because every different line has its own turn and all that kind of stuff, all that kind of different parameters. But a good proportion that usually works for me is 0.5 or 0.75. This meaning it's 75% of the original value, and this 50% of the original value. Then what we're going to do is we're going to take whatever this is multiplied by this, and what we're going to do, and that's going to equal to the result. So let's go back to our 100 example. Our light sensor is on white. It gets 50 back because it's minusing by the threshold value, or our target value almost. And then what it does is that it puts that into this scaling block, and this scaling block puts out an input of 50 times 0.5, which is 25, 25, which can now go into our steering, therefore resulting from a value of 100 going to 25. And now let's revisit our loop concept. What we can do is we have all these different parameters. We can have it go on for time. We can have this go on for counts, but I wouldn't recommend counts for this specific application. We can go on until our touch sensor, until like our robot hits a wall. We can go on. This is what I always do. We can have our robot go on for 1,000 degrees, and that's basically how we can create a proportional line follower. And it's really cool watching your robot follow the line, and it might take a couple goes at it, but if you can understand this code, it's extremely useful, and I would 100% recommend using this code to improve your robot's reliability in this year's FLL season. So now let's talk about variables. Now, where would the variables play into? Like, why would we want to use variables? Well, one thing we'd want to use variables for, especially in this case, is in here. So here we have our operation factor, right? Or our proportion, remember that? So what's happening here, suppose you want to edit the proportion, right? Rather than trying to understand where the proportion is, you can name something, maybe make a name called proportion. And what we can do is we can change this to proportion. And then what we do is we can change our value here, rather than, it makes it, changing our value here, rather than changing it in here. Because sometimes when you have advanced lines of code where it's like sheets and sheets and it just piles on, especially in EV3 Mindstorms, it's very good to use your variables and define your variables at the front, rather than going through each separate piece and changing it there. It just helps a ton. And if you want to use the variable in a different spot, all you have to do is drag it to somewhere else. So basically that's one place you can do it. Another thing we can do is if we were to drag another one out, we can put target value, and what that'll do, just arrow over to the screen. What that will do is now, if we were to read the numeric value of a target value, if we were to put this into our threshold value or a target value, we can now control the target value from outside the loop, which is useful. We'll talk about that in our advanced coding class. So here we have our target value. If we want it to be 50, now we can edit it. Now remember what I said before, it can't be 0 or 100, because those are the extreme maximums and minimums, and you would not want to do that. But you can do, like, I would recommend anywhere from 20 to 80. 20 being mostly black, 20 being like 80% black and 20% white, and vice versa for white. But those are the extreme values. I wouldn't recommend doing anything more than that unless you have a very high proportion, which I wouldn't recommend, because then your robot starts jerking side to side. But this is basically the concept of proportional line following. And make sure when you're putting your loop on, it's on one of your larger motors, your driving motors. Otherwise, what's going to happen is that it's going to keep on going. If you're supposed to have the medium motor on A, what's going to happen is it's going to keep on going on until that medium motor or that motor reaches the value of 1,000 degrees. And if the motor is not even moving, theoretically this loop will keep on going on and on until you decide to stop it. But I'd recommend also speed, not going, especially for specific operations, not going above 20. And yeah, proportion 0.5, 0.75, target value I recommend keeping it at a solid 50. And now, let's watch a video of this code running on our FLO mat. Here we have our robot doing a nice steady line follower. You saw that how the light sensor, let's go down from here. This light sensor, if we remove these things, is following 50% black and 50% white. The robot is going nice and smoothly, not jerking a lot, because we have a gain of 0.75, or a proportion of 0.75, meaning it's only 75% of the original value. And that is a video of proportional line following. So, after watching those videos, you saw how we can use proportional line following to align to the difference between white and the black lines. And we saw how threshold values made a huge impact, and even scaling. And the corrections would be huge if the value wasn't scaled down. And all of these previous components that we've learned have been building up to create this code. And this code requires a bunch of different components. See, as you see here, it has our variables, which define all our values. We use our color sensor, measuring reflected light intensity. We use threshold values. We use scaling. We also use our loop block on motor rotation. It has a bunch of different values and bunch of different coding features and components that you can combine together to create a proportional line following code, which is actually very interesting. But that's really, yeah, edit this. Adam, edit this.